Welcome back, lovely humans. We are going to be doing more with, you guessed it, arithmetic series. The problems that we're doing today are from section 10.1.4. We'll be starting with 58 and working our way through 10-61. By the end of today, or by the end of this lesson, you'll be more familiar with a new type of notation. We usually call it sigma notation or summation notation. You can practice drawing that thing. The key is to try to make it like a nice symmetrical thing going on in the middle. Anyway, we'll get more practice with that later. So first we're going to look at another way to think about how to find the sum of a series. So I know that we've been talking a lot about this, like first term and last term, adding them up, using the rectangle model, all these different things. We're going to look at one last way that you can think about it in 10-58. And then in 10-59 is where you get introduced to this new notation. So 58 should feel mostly like review, hopefully. And then so I'm going to leave you to do 1058 and then read through and try 1059 as well, and then we can go over it. All right, 58, we have, part A is really just describing what you see, so shouldn't be too bad. Basically, he just writes the series twice, except the first one's forward and the next one goes backward, and then adds them up and down. So he ends up with 101, which is added repeatedly over and over again for a total of 100 times. So to get S, then, so for part B, if we have 2 times S is equal to all of this, then S would just be equal to all that divided by 2, otherwise known as 5,050. Remember, there are 100 of these, so 101 times 100, and then divided by 2. That would be S. For part C, so you can relate this back to what we were doing before with kind of the area model. To relate this, you could think about it as, you kind of just like piece together that it's the same formula. You can also think about it as adding a second rectangle. Basically, like you have all the values and then just taking another one, sticking it on top to get double the area, and then dividing it in 2 to get just the area of your rectangle. So again, just your own connections and observations for part C. For part D, if we are going to use this kind of formula, we do need to know how many terms there are. So the way I like to do that is, the way you can do that is that you know that the nth term, which we're trying to figure out what n is 59. So 2 plus 3n minus 3 equals 59. So then we get 59 equals 3n minus 1, 3n equals 60, and n is equal to 20. So to fill this in, the first term we know is 2, the last is 59. There are a total of 20 terms, and then we need to divide it by 2. And we should get 610 as the answer for 58. For 59, we're introduced to this new notation. So give me a moment, I'm going to write it up on the I'm back. So if you have the, we're introduced to this thing called summation notation, otherwise known as sigma notation. This is sigma right here. You may recognize it. It's a pretty popular Greek letter as far as Greek letters go. And what it means, I've kind of color-coded it here to help you understand. It's really like a shorthand, because mathematicians love shortcuts, right? So instead of writing out like a whole list of numbers, you can just write it like this. So it takes some getting used to, but once you get used to it, it's super handy. Especially when you go on to calculus. So I hope you all get the chance to take calculus at some point in your life. It's such a beautiful type of math. Really everything that you've ever learned comes together, and you can use it as such a powerful tool in so many different contexts. But I digress. So, this right here means it represents the sum of all the terms of a sequence, and the sequence is defined by an equation, T of C, or T of N if you want. Doesn't really matter what letter you use here and here. Starting from the 8th term, right? So it tells you where to start down here, and ending with the bth term up here, right? So it's like, we're going to look at an example. So in part A, we have a sequence, and there are 5 terms. So first, let's find out what the equation is. So in this case, our equation is, we're growing by 4, so we have 4n. I'm going to use n this time because it's familiar. And then go backwards to find the 0th term, we have 11. And how many terms are there? So we're going to sum them up. We want to start from the first term, so that's going to be n equals 1. Notice that this value, or this variable, should match this one. We're going to start at n equals 1, and then go all the way up to n equals 5. And that is how we would represent that using our new notation. Part B kind of asks you to go the other way, so it tells you that it wants the values from 1 to 6 of the sequence that's defined by n squared, or in this case t squared. So that means that we are going to find t of 1, or the sequence, the first term we're going to find with t squared. So 1 squared would be our first term. And then we keep going, so the second term is 2 squared, so that's going to be 4. And then 3 squared, 4 squared, 5 squared, all the way up to 6 squared. It tells us where to stop. So just find out what those are, and you add them up. You should get 91 as your answer. You can't use any sort of shortcut with this guy because it is not an arithmetic sequence or an arithmetic series. It's quadratic. But you can, it's not too bad to add them up or use your calculator to do so. Cool stuff. 10-60, give it a try. It's a little bit weirdly set up, so it refers back to problem 10-51, which I believe was a homework problem. It's okay if you didn't do it. Just know that you are going to have to come up with the equation of each of those separate sequences before you can use the notation, right? That's the first step. Got to figure out what the rule is. Okay, so I'm going to leave you to 10-60. Be back in a moment. Alrighty, 10-60. We've got 2 parts here. So for the first part, the top line, 5 plus 10 plus 15 and so on. We are a sequence that is growing by 5 each time. So we got 5n. And the 0th term is just 0. So that's what we can fill in 5n here. Then we need to figure out how many terms we have. So we know that we're starting, if this is our rule, the way we wrote it, we start at the first term. So we can write n equals 1. And then we need to figure out 400 is what term. So you can plug it in. 400 equals 5n, so then n is going to be 80. So we're going to go from 1 to 80, and there's our answer. Similarly for the next one, in this case I actually decided to use m. Usually if we have 2 different series, we like to use a different letter, so why not use m? I'm particularly partial to M because it is my first name's first initial. The this one right here, so we are growing by 5 once again. Actually, I'm going to do it in red so that we can keep our color coding up. So we are growing by 5 again. And this time, if we find our 0th term, 3 minus 5 will be negative 2. So that's what we fill in here. It's helpful to use the parentheses so that you know that you're taking the sum of all of it, rather than like the sum of 5n and then subtracting 2 at the end. Super different. And once again, we're going to start at the first term. We're going to use m, which I should have used here as well. I was like, I made this whole big deal about using m, and then totally didn't. Love that. Okay, there we go. And then we are going to go all the way up to 80 again. So you can do a quick calculation if you want. 398 equals 5m minus 2. Add 2, divide by 5, m equals 80. So that is what we are going to do for part A. Part B basically just asks you to add them up. So you write this whole thing plus that whole thing. Yay! And that's all for 10-60. Last problem, it's a short classwork for today. So try 10-61, A, B, C, and D, and I will be back to go over it. Alright, let's do this. 61 part A is written in summation notation. It tells us that the teeth value, I don't know how else to say it. The teeth value is going to be negative 5 plus 13t. So we can find the sum just like we have been. So we're going to take the first value, so plug in 1 for t. Negative 5 plus 13 is 8. And then f of 10, so we're going to do negative 5 plus 130, that's 125. And we plug it in our formula, 8 plus 125. It tells us there are 10 values because we go from t equals 1 to 10. Calculate that out and you should get 665. Part B, they give us one of those fancy little pictures they like so much. And from that, we can see that the first value is 105.5, and the last one is 6.5. I should say the 23rd one. Once again, you plug it in, so 105.5 plus 6.5 times 23 divided by 2 to get 1288. Part C, the first value is 4, it tells you that. And then it tells you that the nth value, it gives you an expression. So 4 plus 6 times n minus 1. So we can still plug that in the formula. The first term is 4. The nth term is 4 plus 6 times n minus 1. There are n terms. We're going to still divide by 2. Simplify this guy. You will get 8 minus 6, so that's going to be 2 plus 6n. You simplify all that, times n divided by 2. That's going to be 2n plus 6n squared, all divided by 2, which is n plus 3n squared. Whew. And last but not least, another summation notation. Our function that we're dealing with is 10 minus 5t. So we want to evaluate the first and the 30th terms, as it says at the top and bottom of our sigma. So the first value is 10 minus 5 is 5. The 30th value is 10 minus 150, so negative 140. We can plug it in our formula, so 5 plus negative 140 times 30, all divided by 2, to get negative 2025. Woohoo! And that's all for today. So let that sink in a little bit. We have this new notation for handling the series, and got more practice with finding the sum of series. So have a great rest of your day.